All right. We're live. Let's get to it. I started late today, so yeah, of course, it's a 30-minute stream, but let's just do it. So we're doing. I mean, it's Rust links, yes, and it's Rust links, and we are on error handling. We've looked at the README talks about the things that we should learn or we should know about to be able to solve the exercises in error handling. So we've looked at error handling from the Rust book itself, generics, result, and then now we are unboxing errors, right? So that's where we continue with this today, and that is in the Rust language reference, not the Rust book. So yeah, so that's this one. So we were I think we yeah, boxing errors. Actually started boxing errors yesterday because this is what we solved this problem yesterday. So we continue. I think we should be yeah. Actually, it's other uses of. So this is what we'll continue with today. So let's go on. So I'm gonna go through this, see where we leave off. Maybe try a few examples. Yeah. So let's continue. The other uses of the question mark operator. So notice in the previous example that our immediate reaction to calling parse is to map the error from the library into a box error. Um, okay. Okay, that's what it was talking about box error. So basically I'm referring to if I take this here. So yeah, this is what we did yesterday. This was our code. We had a function called double first that that takes a vector of a reference to string slices and returns a result type, a result alias that we created, which is this result alias here, which is just a shorthand for result and double error. And yeah, so it just returns that so that we don't have to explicitly write out the double error every time, right? That's it. And then it gets the first element of the vector, which will return as an option of refers to a string slice, and then we were converting this to a result type. Otherwise, we map that to an error. So is this what it was referring to as boxing the error? Actually, no, not here, not here. But again, this would actually return okay, or to convert the error to a double error. It's the and then part it was talking about there. So and then it would get the value in the OK variant of the result, and it will call this function where it will try to parse, and then it would try to map it to an error. So it maps the passing error into a double error. This is what it was calling boxed error. Okay, is to map the error from a library error into a boxed error. Okay, so that's. Oh no, wait, hold on. We didn't do this. Wait. So this is what it does here. It's like map error and then it does e dot error dot into. Mm, so, but we does okay. No, hold on. But we didn't. That's not what happened here. Look. Oh yeah, exactly. So that's true. Okay, so I think we went one step ahead of ourselves. So I think we were supposed to. This is what we did. Yes, this is what we did previously. This is the code we have here. All right. So now we should be looking at boxing errors. Okay. Okay. So let's come back to it. Okay. A way to write simple code while preserving the original errors is to box them. Is the box type. So box is a struct. Yeah, box is a struct. Mm, so box type is a pointer that uniquely owns a heap allocation of a generic type. It's just a pointer that uniquely owns a heap allocation of a generic type. So the box type would this pointer would live on the stack in this case. It has an where A implements allocator and C implements size. So you have implementations. You have a box din any. So attempts to downcast the box to a concrete to a concrete type. Is an example here. So print if string, you have a value as a box din any. I don't know what the din is right now, but I guess that's not important for what we're doing, but we'll learn about it later. We've used it already, but yeah. So if let okay, if value that's downcast that you try to um convert to a string, if this is possible and it um gets structured into okay and a string value, then you print this. Okay, this is an attempt to downcast to a concrete type. Okay, so now you do how you use it is hello world, that's a string, and then you create a pointer here using box new, and then you pass the value, which is in this case the generic type, which is any now. So Rust has any type, and then okay, I'll be different any and a generic type like T will be. But anyway, okay, and then you can also use something like this. Okay, any is a trait. Any is a trait that has a static lifetime. So the trait to emulate dynamic typing. Most types implement any. However, any type which contains a non-static reference does not. Um, of any trait in Rust. Why not just what's the purpose of the generic trait, right? Um, and type erasure. We don't have. Do we have the concept of type erasure in Rust? We don't, right? So this is Java concept. What any is? So any is a special trait for type reflection. Okay, dynamic typing. Okay, so it lets you erase the concrete type of a value at compile time. Why would you want to do this? Uh, okay, yeah, okay. Let's you erase the concrete type of a value at compile time, storing it behind a trait object boxed in any or in any. So you just give a pointer to something in a heap. Later, attempt to recover the original type using as runtime using downcast to the type. Yeah. Basically, you can do you can create a pointer to that value in the heap, and then you can try to downcast it later on to give you a result. Yeah. So okay, this works because any stores type IDs internally. allowing safe runtime checks. Why not just use generics? Yes, there is sort of a different problem. When with generics, the compiler knows the exact type at compile time. With any, the type is erased until you explicitly need downcast at runtime. Okay. Yeah, yeah, okay. Hmm. So this is a generic version. Compiler knows T here. You can only work with T in ways constrained by traits. But now any version, compiler doesn't know the real time of X. You can try to recover it dynamically. Okay, when you would use any plugin systems or type maps where you store heterogeneous types in a single container, dynamic casting framework, CG, GUI libraries, GUI storing arbitrary event payloads. Okay, so what that looks like is um uh, okay, we cannot have that, but that looks like in the main. Wait, no, not main. In my function, I can say it's like box or whatever. So in this function that returns unit type, I can say I can basically, so this is box types, yeah. So I can, so wait, hold on. So a box type is a pointer to a location on the heap. Yeah, just a pointer to a location on the heap. Yep, that's it. That's what a box type is. So I can say let X, that is a box type. This can be Dean any. Silly. Do I need to specify where any comes from? I guess I need to. I need to bring any into scope, yeah. Standard std.any, yeah. So std any, yeah. So and I can say this should be box new. Um, this is a string, yeah. So we can do this. This is stored. Wait, with box type. The pointer is stored kept on the heap here. Almost. So it is smart pointer, yes. The pointer itself lives wherever the box lives. What? Pointer itself, a word size value like the thing lives wherever the box lives. Stack, heap, or inside another struct. The data is allocated on the heap, yes. So if I do this now, here, X, the box pointer lives on the stack. Ah, yes, that makes sense actually. Wait, uh, okay. Yeah, yeah, this lives on the stack. The integer lives on the heap. Yeah, in this case. Yeah. So even though it's an integer value to live on the heap, what about box the any? Yes, so this cannot live on the stack, right? Okay, when you write box in any, uh, when you write box in any like so, the box pointer itself is still on the stack. Yeah, which is what I would expect actually. The din any, okay, what's a V table? V table pointer plus data on the heap. So heap allocation happens for the value. Yes, heap allocation happens for the value. But the handle box is stack allocated or embedded wherever you put it. What do you mean? From a box T is stack allocated pointer to the heap. The stack allocated pointer to the heap allocated T. The pointer box stays wherever you store it, often stack, but the actual value is stored on the heap. Yes, I think that's what I'm saying, but that's what I said, right? I think you just said exactly what I said. The pointer itself is stack allocated, but the memory location that holds the data lives on the heap. Exactly. That's what I said before. Yeah, that's what I said. Okay, just a small pointer. It says box P itself is just a small pointer size value, which is wherever you put it. Common understand. But could be inside. Oh yeah, could be inside another struct. Okay. That's the catch. Okay, could be inside another struct, inside the vex. Uh, okay. Yeah, exactly. So it can leave wherever you put it. Common in the stack, but it could also be inside another struct, inside the vec, etc. The original would be box that the pointer is kept on the heap. Slight correction. The pointer is not on the heap by default. Uh, oh, this was my original question. Okay. Pointer is original, it's on the stack, yes. Okay, so give an example of where it's on the heap. Give an example of where the pointer is on the heap, like in a struct, like property of a struct, sorry. Yeah, if a box is inside another struct and that struct itself is on the heap, then the pointer lives on the heap as well. Yep. Okay, so I think that's clear. That's clear. We got that already. Okay, so this is it. Uh, so we can do the allocation like so. I also want to see what happens when I do let y and I do this like five. 5. Yeah, it's I32. Okay. I wanted to see what the type is gonna be. Okay. So now after uh, so the pointer X here is going to be on the yeah, this is a string literal. I can actually make this is I can say to own well just say string from I'll make this string an actual string. So this is going to be on the heap. So we know that this is going to be on the heap and this this would be on the stack, yes. Now after we do this allocation, so we have the pointer now, right? So we have a pointer now. We can use downcast method to try to get the value. Um, what did we say? Hold on, let me see. So this is, I think, with any we were seeing in Downcast. I know. I mean, I'm trying to get. Yeah, yeah. Um, I'm trying to remember what they said about. Uh, at what point that happens? Is it on? I think it was here, right? Yeah. So wait, not here. Yeah. So with any the type is erased until you experience Downcast at runtime. Yeah. Okay. So this is happening at runtime. So here we can say. Now we want to get back the value from here, right? We can actually do x dot downcast and then use the turbo fix operator and say give me this as a reference to string slice. I want to see what happens here. Um yeah, and I can say let y just even do y equals. So yeah, it's going to be a result of this or now even that is not an error actually. What is a boxed in any? That is super interesting. So let's see what we get. All right, so print line y is let's say y dot actually we can do why can't I do this? Um actually I can, yeah. So actually it's the value content in the box. And how do I get what is inside the box? Is it get returns no? How do we get what is inside of a box type? Um hmm. So you get the box. Okay, this is unsafe actually. Downcast unchecked. So you have downcast unchecked. You have so okay, wait, hold on. It's a result, right? It's a result. So okay. Hmm. I think this is not supposed to be like so, right? If I remove this, what do I get? It's just a box of string. Yeah, it's not exactly okay. Yeah, no wonder. It's just a box that has string. So I did okay, that was not correct. So yeah, no wonder. Yeah. So now if I say downcast this, yeah, the type will not be correct. I think I already see the complaint. Yeah. Uh was dropped, no method name downcast. It was strange. X dot why won't I be able to downcast this? So downcast is a concrete type. Okay, yeah, this is not actually so this is you're creating a box actually. So this is not a concrete, this is not a generic type. So there's no okay, so when you have a generic one you can you should do that, right? But what if I had um wait, one size if I had hmm, I need to see this. I need to try something. Okay, I think I didn't know about this. Yeah, okay, I think I've seen this before actually. Does this only work for, so I can say 100 and I can say U size. I mean U 8, and that'll be the type. Can I also do that for no? Of course not. I think it's for only int types, okay. I mean no, wait. Okay. But anyway, so I mean I can just try to do U8. So I think the example that we had before was going to be fine because this is the type here U8. This is boxed in any. So why not? Why not the type I had before? Why not this boxed in any? That's exactly what is here. Yes. So I should be able to, yeah. So regardless of whether this is saying boxed in any or boxed in string, it's any that's there. This was fine. What I had before was fine. So I should be able to downcast this, you know? Yep. Um, yes. So now I have a result. I have a box that is a result. And now I'm gonna say if let z, yeah. I mean no. If let okay z be y, then do this. I mean if you can destructure this and it's okay, then this is my value here, right? So now print line and tell me that value in box is z. Excuse me. Okay, box is never used. So just print box for me here in the end. I mean box. Okay, I think this will be the last one I do and I'm done tonight, right? So yeah, we continue tomorrow. Yeah, value in box is this is string. So yeah, okay, so we get the value from the box. Yeah. Even though it still shows like that is in a box, but that's fine. Can I get you don't get any value out of, I mean you cannot, so let's see. Is there a way to is there a way to no. What's the standard way to get value in a box in the box type? Example. Um, example. Z is of type box string, not exactly string, but still prints out this is a string. Okay, so the key is box C implements def. Okay, but when you use downcast, the result is still box T, not directly T. So you have to dereference. Yeah, okay. No, no, that's not. Okay, you have to dereference it to get the inner value. or use it as is because display and debug work with box string as well. Okay, so we either dereference it like so. Wait, I suppose is what you mean, yeah. So what if I did this is not able to do that. I mean, this is not. So you have okay. Oh wait, what if it's here? Doesn't work either. Um, I mean, I want to see the type of. I want to see the type show me as like string. Yeah, string, not box string. Oh, okay, yeah, it is. Okay, I see. When you dereference it, then you get it. Okay, that's what I was talking about. Okay, so either we dereference it or we use it like that because um, display debug is implemented on that, right? Okay, that's fine. So you deref it with this to give you string, or this in the context express a reference, or possibly directly. Okay, that's fine. That's fine. So we've looked at the box type. I mean, all of that was us just looking at boxed, right? Okay. I mean, I was trying to grasp certain concepts around uh, box type. Yeah. Okay, what it means and all of that. That's fine. I got it already. So we'll continue tomorrow. Yeah, we'll continue with this tomorrow. I mean, I'm gonna just write this function, and I mean, the only what I see here is there are a couple of subtle differences, right? I see that. I mean, compared to the former code we have a what an empty vec. No, we implement error for empty vec. So we have an empty vec. I think we already have the empty vec. Yeah, implement error for it, and then there's into. Okay, so we convert this. Okay, I mean we'll learn about this tomorrow. We also do. We also convert here. Um. hmm. Okay. Yeah, I think I already see the subtle difference because this is the difference here. So the difference is that for the other one we had result, it was a generic type and double error, but now our alias here is result of our type and din error, so any type of error whatsoever. And we need to be able to convert. So let's not get ahead of ourselves. So that's tomorrow. All right, then see you. Have a good evening or morning or whatever. Right. See you tomorrow.